Greetings, everyone, and welcome to today's event, Data Management 301, Tackling Risk, Complexity, and Growth. I know that the next 60 minutes will be very informative. My name is Paul Clanton. I'm a former local government CIO, having led city and county IT departments for more than 20 years. I'm now a senior fellow for the Center for Digital Government and a leadership coach helping public sector CIOs to dramatically transform their individual and organizational effectiveness. Today, I'm honored to be your moderator, and I thank you for joining us. Before we begin, I have a few quick housekeeping notes that I hope will help you get the most out of the webinar. First of all, a recording of this presentation will be emailed to all the registrants within 48 hours. And you can use the recording for your reference or to pass along to colleagues. If you would like to download a PDF of the slides for this presentation, just click on the Webinar Resources widget at the bottom of the console. This webcast is designed to be interactive. You should see a Q&A box at the bottom left of your screen. Please enter your questions there at any time. Our speakers will address as many of these questions as they can during the webinar. If during the webinar you'd like to connect with your peers in real time via LinkedIn, Twitter, or Facebook, please use the hashtag GovTechLive. At the close of the webinar, we'd love your feedback. We encourage you to complete a brief survey that will pop up once the webinar concludes. If you're not able to stay with us for the entire webinar but would still like to share your thoughts, please click on the survey widget at the bottom of the screen to launch the survey. At this time, we recommend you disable your pop-up blockers. And finally, if you're experiencing any media player issues or have any other problems with the webcast, please visit our webcast help guide by clicking on the Help button at the bottom of the console. Joining me today to discuss this very timely topic are Otto Dahl, former Minneapolis CIO and a senior fellow for the Center for Digital Government, and Sean Darrington, senior director of product management for Storagecraft Technology Corporation. Otto Dahl was the Minneapolis CIO for over 7 years and was responsible for all city IT services. Prior to that, he was the state of South Dakota's CIO for 15 years with responsibility for all state government computing, telecommunications, state radio, and public broadcasting. While with IT research firms, Otto advised Fortune 1000, federal, state, and local government CIOs on information technology assessment and alignment to business needs. He has served as a director with the United States General Services Administration, developing information technology strategic plans and oversight policy. Otto received his computer science degree from Virginia Tech and is a senior executive fellow of the Kennedy School of Government at Harvard University. He is a past president of NACIO, a national organization of state CIOs, and he is also a past president of the Metropolitan Information Exchange, a national organization of city and county CIOs. Finally, he was named to Government Technology's Top 25 Doers, Dreamers, and Drivers. Sean Darrington is the Senior Director of Product Management at Storagecraft. He has more than 20 years of storage experience. Prior to Storagecraft, Sean led product management at Exablocks, which was acquired by Storagecraft, and Veritas Semantic. He has held multiple product marketing and management positions covering storage management, cloud, and virtualization solutions. Before Veritas, he was the lead storage analyst at Metagroup. Sean holds a BS in Material Science and Engineering and a BS in Engineering and Public Policy, both from Carnegie Mellon University. With the housekeeping out of the way, it is my pleasure to turn the webinar over to Otto Dahl. Otto, up to you.
Thanks, Paul. You know, it's been interesting over the years dealing with storage, as we always have had to, since it's a key component of the IT infrastructure that we support. And I think in the last couple of years, there's been a situation that has occurred that has really brought data storage more to the forefront on the minds of IT organizations and CIOs. And I believe that to be the ransomware attacks that we've seen, particularly on government entities. And in particular, this has risen to the level that the public at large is getting to understand and see the ramifications and what goes on. As you can see from an article that came out last month in CNN, where the national media has been looking into sort of the degree to which this happens. And I think there's really three things that I've taken away from these incidences. One, there are obviously more attacks that go unreported. Two, that unfortunately the bad actors have had at least 6 years to hone their skills and are getting more creative all the time. And then, of course, it's not only happening to cities in the U.S., also counties, states, federal government. We all have the same issue and the challenge. And it's really driving how well we protect and manage and care for our data, because ultimately that is the value that the bad actors are looking for. Even within the educational community, I found this a while back. The K12 Cybersecurity Resource Center has this K12 Cyber Incident Map that they maintain of events, and if you see anything with a yellow pin, that's a ransomware incident. Blue pins are phishing attacks, and the purple pins are data breaches through various means. And so as you can see, these things happen, and again, I feel that they're not necessarily able to report on everything because we're not seeing everything that's going on. And even in higher education, there's a challenge that I think is fairly unique. In the industry, like to view that as a unique attack surface. And it's because academia really is an environment that needs remote access across multiple device types. They've got a high degree of content sharing that they do amongst themselves and with other institutions, with the press, the public, et cetera. And they also have, in addition to personal information that they need to keep protected, but also they have a high concentration of intellectual property. And when you throw all that together, that's really a very rich source for bad actors. And so hence, they are big targets of folks that do ransomware and unfortunately other nefarious acts. What I'd like to spend my time doing is talking about those areas that you all should have on the top of your mind that you should be addressing, and in particular, any implications if we don't address these areas specifically. And what I'd like to do is just go through each one of them, and I'll start with backup and recovery. You know, everybody has some degree of disaster recovery. It's been a well-developed approach to things. Business continuity has also come about in the last 8 to 12 years of people really looking at the impact and how they can ensure that we maintain our services, particularly in the government space. Most definitely, if there are disruptions, we're probably going to see at least a cash flow disruption. There's possibly also revenue loss. Obviously, an institution's trust quotient goes down with the public and the business community when these sorts of incidences take place, and if they're not handled well. And so there's a lot of pressure on us to ensure that we have plans in place for continuity of our government programs, as well as our ability to deal with natural and man-made disasters as they occur. And I think that one of the largest things that really affects this is the ability of agencies and departments within governments to actually pay for providing these services in their day in and day out IT infrastructure that they make use of. And I'll talk a little bit more about that later on here. The next area, of course, is we've got sensitive data. We need to secure that data. And to me, I think what's really surfacing is the fact that we really have to pay attention when our data is at rest. Sure, we've got to secure it while it's being transferred around, but it's all the more important our ability to ensure that when data is sitting someplace, and data doesn't necessarily always reside within our on-premise data centers. Today, we're implementing hybrid clouds, and we're using packaged solutions from industry, and so it's really important that we manage wherever that data ends up sitting, whether it's on a remote device, whether it's in someone's office on a desktop or a laptop that they're using outside of facilities. That's really, really critical for us. Another is that we need to provide the ability to prove the chain of custody of information. And a couple examples for that. One, a lot of times, especially in government, the best example I can give is in the case of dealing with law enforcement, the judicial, and the incarceration processes that government carries out. Those processes are typically carried out across jurisdictions. And so one's ability to ensure that we get data successfully moved from, for instance, a city law enforcement organization into the judicial world, which is probably sitting at the county level, on over to ultimately if there's incarceration of offenders, not only within the county's facilities, but probably also those going into state institutions. And so as you can see, that data really moves around, and we have to ensure that that is what is important for us is to really prove our what I like to call the chain of custody. And then finally, auditability leads to ultimate data integrity. If you look at things like elections, our ability to, number one, show and prove chain of custody of votes, but most definitely our ability to do recounts and that sort of thing is very, very important to our constituencies, and that is something that we end up having to supply a lot of security for. Now, of course, we all know about data volume. To me, though, it's really interesting. It goes beyond just data volume to data formats have exploded. Some of these formats have a price to pay, if you will, for having them, as I'll talk about in a moment. And also, there's this concept of surges that I see within the government world. First of all, volume. Open data, great concept. Here in South Dakota, here in Minnesota, we have a law in the books that requires everything to be open unless it's explicitly exempted. And so ultimately, literally, any government jurisdiction within Minnesota has to not only maintain the data for their systems of record and their day in and day out operations, but also has to turn around and then make that available, that information available in multiple formats in an open data space that the public and the business community can get to. And so literally, theoretically, just about duplicating what we have in the way of the data that runs a city, for instance, or a county, or the state itself, has to be replicated ultimately online. Another thing is the increase of video as a medium, of course, is out there, and it comes from stationary cameras and mobile devices and body cams for police, dash cameras in squad cars. There's just an awful lot, but I don't think people recognize there are a lot of other scenarios that are also taking place. DOT and public works departments are out there mapping road surfaces by running trucks over their roads to determine the status, the state of the road system, of that infrastructure for a locale. People are making use of drones. A lot of that is visual. And so there's a tremendous amount of volume. And again, the format of video is very different. It's obviously a lot of volume, and so that provides all sorts of challenges for us. And then finally, this whole issue of the Internet of Things, of sensors, if you will, producing data. And it's not only what you might produce as an entity yourself, but also, as important, I think we need to pay attention to what the commercial sector is wanting to see from us as government entities. In particular, the best example I can give is autonomous vehicles. And there's, the commercial entities are actually asking for information from cities and locales that allow them to see things like information that we're maintaining in our traffic systems. They're going to want some of our infrastructure to actually be sending out information about where they are and what it is and how it changes over time, et cetera, et cetera. And so you're seeing an awful lot of dialogue going on today as people try to figure out how are we going to deal with not only the volume, maybe some of the formats might be different, but most definitely where it's coming, who are the actors, can we verify that something is truly coming from or going to the right people, et cetera, et cetera. And then finally, I would add that government has got programs and functions that it performs that really come in surges. I think the one that most people can recognize right off the bat are our elections. We don't hold elections every day, but we may, come and have a primary and then a general election, maybe a couple of general elections in a year. And so there is a ramp up of use and storage of information for all the points that I've made up to this point. And there's also other functions. Property tax assessments are typically done in a relatively short period of time because that's something that has to be set up, and public and business owners need to see what those assessments are so that they can plan and over the course of a year and pay and make payments, et cetera. And so what we end up doing is we go through a lot of effort, we collect a lot of information, we do a lot of processing, and so we have this surge of activity that turns around and basically hibernates for a better part of the year until we go back through the process again. And so you see that in any number of functions within government that we have to turn around and be able to effectively, both from the standpoint of technically, operationally, as well as from a cost perspective. Another area that I think folks need to spend a fair amount of time on is we all have records management processes and an understanding of what we specifically want to try to do with our data over time. And one of the important areas is this whole retention policy arena. Data disposal challenges are numerous. It's great to say we're just going to hold on to data forever, but we need mechanisms that allow us to cull information and to ensure that we can manage the tremendous amount of information that's only exponentially going to grow over time. In particular, I think that what I call this compression allowance is, it comes in two flavors. I think when you hear compression, you're thinking, gee, you know, can we spend resources to compress, to save on space whenever we need that data again, then we uncompress it. It takes resources to do that. But I think another form to me of compression is when people decide that they're going to summarize data so that they can ultimately throw away or maybe even move offline bulk, or if you will, raw data. And so those sorts of things are being addressed by institutions' records management plans and programs that they have. And so any storage world has to really tie into these sorts of business needs that governments end up having to address. And then finally, my point with storage generations, in the old days, and I've been around IT now since the 70s, it used to be, what do you do with the tapes and floppy disks and all this external media as that evolved over time. But more importantly, today, it's the challenge of changing out our storage capabilities over time. And that obviously comes at a cost, as we would see in any sort of transition of technology. And that's something that has to be managed wisely, because again, those costs are things that's not usually where the political sphere, as well as senior civil servants in government organizations, really want to spend their dollar. And then finally, I'd just like to say a few words on cost recovery support. As a CIO, one of the biggest challenges I felt I had was the ability for me to produce varying price points for things like where a department or an agency could store its data, what sort of level of disaster recovery could you have? Did it have to be immediate? Could it wait? Are we going the wrong way and allowing something to not have the level of recovery that really is necessary? And so that's a challenge, I think, that every CIO faces at some point, because ultimately departments and agencies come in all sizes and they come in all levels of funding. And so our ability to provide these capabilities across the enterprise as a whole, if we're lucky, we can structure things where maybe folks without sufficient money to do the level of support that they really should have is available to them, versus being able to somehow cope and provide these capabilities at different price points for folks that have different abilities to pay. And in particular, I think that the things that we have to keep an eye on is obviously the importance of the data to the operation of a city, county, state, federal government, whatever. There's obviously various laws and ordinances that we have to abide by. There's also requirements that are thrust upon, for instance, states and locales by the feds and locales by the state. And so, and each jurisdiction can create its own laws or its own ordinances. And so we have to take those into account. And then ultimately, what are the program requirements? What are we trying to do for our constituencies? When you throw that all together, the ability to have storage costs being manageable in this way is very, very important to an organization, obviously to the IT department and CIOs. And so I really think those are the things that people have to be very sensitive to. And with that, I'll turn things back over to Paul.
Thank you, Otto. And I'm just going to turn it right on over to Sean. Sean?
Great. Thanks, Paul. Otto, thanks for the insights in the beginning. It was very helpful and informative. I appreciate that. As we kind of put what Otto talked about in terms of some of the major challenges into context, obviously, there's a lot of theories that we have to, think about, but then ultimately there has to be some solutions that support those opportunities, but also hopefully mitigating that risk and complexity around storage and data management. And so what I wanted to do is share a little bit about what StorageCraft is doing with regards to tackling this risk and complexity and growth and enabling you as agencies and educational firms to actually think about slightly differently how are you going to tackle this, what was a very targeted one-off cybercrime, ransomware attack for notoriety, whereas now, today, it is a business. It is sometimes foreign agencies and foreign government businesses, but I think everybody on the call has this mindset. It's not a matter of if you'll be infected or if you will get hit. It's a matter of when and what are you going to do about it, right? And so certainly from a ransomware perspective, that's one angle of risk that you have to mitigate. And then also the opportunity for, education and other agencies where phishing attacks and URL spoofing is another, you think of it as another form of ransomware, but there's another attack vector that can compromise data. And that is just as important to think about from a security perspective as ransomware. And so there are areas that you certainly have to think about the perimeter, making sure all the AV definitions are in place, firewalls, et cetera. But once you get beyond that and you assume that you are going to be infected at some point, how is that going to manifest itself in terms of storage management and data protection approaches and technology that you can use to recover in the event of a failure? And that failure might be ransomware, that failure might be just a system failure, a hardware failure, operational incident. And so what we've done here at StorageCraft is really taken the next generation of offerings, and OneTape is our converged scale-out storage. This is what we've designed from the ground up over the years that includes our capabilities for scale-out storage. And I'll get into a little bit of the differences about what is OneTape and why is it different than the legacy storage alternatives that many of you on the call are used to over the last 30, 40 years. But we also have the opportunity, depending upon the location and deployment options, to have just a software-based solution for data protection for your physical and virtual servers. If, depending upon your deployment, storage isn't a focus, the immediate priority is more the data protection and recovery, you have that opportunity for a software-based solution. And in both cases, whether you're looking at a converged scale-out storage and data protection or just the SLA-based data protection, you have that opportunity to look at different fault domains and protection to actually leverage cloud services where appropriate. And as Otto mentioned, prioritizing some of those applications that are the most important and delivering different service levels, this is where you have the opportunity for the most critical application and actually provide replication into the cloud for full network application and data recovery off premises as opposed to potentially providing local recovery options at a lower price point for different agencies. So with that kind of context in mind, I did want to share a little bit about, we don't have that much time, but I did want to share a little bit about what is unique about OneTape. Most people on the call, traditional storage vendors with EMC, NetApp, et cetera, have RAID and LUN volumes, right? They're built on fundamentally a block store, right? And this is going back decades for the original theory of RAID out of Berkeley, but ultimately, you have files and folders that are mapped to either network shares or iSCSI or fiber channel protocols that are tied to specific groups of disks, right? These are the RAID groups that everybody creates and everybody's familiar with. And that's certainly worked for many organizations over the years, but it's not something that really is going to be flexible for an agile infrastructure based upon the uncertainties that the agencies are going to be asked to do in 6 months and a year. And so what OneTape is we've built our own distributed object store. Those that are familiar with Amazon S3, GCP, et cetera, those massive cloud-scale storage infrastructures are actually built on an object store where you can add any number of drives and it can massively scale to multiple petabytes and exabytes, in fact. We've taken a different approach here at StorageCraft, and we've designed and architected our distributed object store to look like scale-out network-attached storage. So we present, even though we present objects underneath the covers, ultimately it looks like NFS and SMB file systems to your applications and to your users. So you have all the benefits of object storage, the ability to seamlessly scale out and move data around, look at remote replication, things like that. But you have the usability and the compatibility with any application that uses SMB and NFS, whether it be a backup recovery target, whether it be primary storage for unstructured data, whether it be a primary NFS data store for VMware. All those software and protocols that we provide for NFS and SMB, we also extend that to integrate our clustering capabilities with our data protection capabilities. So we have data protection services actually running in the cluster on that hardware that allows us to uniquely and efficiently protect different virtual machines as well as physical servers in your environment. But all the while, we have this architecture that is a microservice-based architecture. You'll see other things added over time. But the distributed object store underneath the covers is really what's unique about StorageCraft and OneTape, because we can provide next-generation software services on top of our object store, which are unique in terms of being able to provide recovery options based upon different events. Right? So as files are being written into the cluster, we actually break up those files and we do inline deduplication and compression. If it's unstructured data, we actually take snapshots every 90 seconds of that file system to provide recoverability of any data that's deleted or modified. In fact, the continuous data protection, those snapshots are actually immutable because we're an object store, and that's a very different factor compared to block store and the traditional RAID and LUN-based systems. Right? We also provide encryption at rest. But because you're not managing LUNs or volumes anymore in a traditional or legacy storage approach of block stores, you actually don't have to worry about this anymore in terms of how much storage am I going to provision to a given application. You can now think about just a pool of storage. And that pool of storage is available to any application you want to provide access to the cluster with, right? As well as you can provide a comprehensive DR strategy to not only remotely replicate that storage to another location, but also into our cloud. And you have different configuration options in terms of drive failure and so forth. But the advantage of having an object store underneath the covers is oftentimes in the ability for, our ability to recover dynamically from drive failures, where you as an administrator don't actually have to replace a failed drive. We'll take actions and actually recover that drive, the data on that drive, without any action necessary. You also are insured, if you will, from bit rot and undetectable bit error rates on hard drives and so forth, where in legacy systems, those files, they don't know that the blocks have actually flipped and a 1 is now a 0 and now that file is corrupt. Whereas with an object store, everything for us is a hash value. So we can guarantee what was originally written to the cluster is actually what you're going to be reading back. And as Otto was speaking about the different chain of custody, that's an important insurance and an important factor to be able to prove to the courts that this file that was written for evidentiary use is actually the original file and hasn't been compromised. Right? And so taking into account these different software capabilities and our ability to scale out and grow from a handful of terabytes to potentially petabytes of problems in terms of storage you're trying to solve, there are different options across our family that have hard drive-based solutions. The 4412 model on the left-hand side, the 4417 in the middle scales up to 200 terabytes in a single 2U appliance form factor. And as you cluster multiple of these together, you can get over close to 1.5 petabytes. But you also have the opportunity to take advantage of an all-flash solution with the same software feature sets that I was describing. So based upon the application requirements and your business requirements, the agencies can actually decide, okay, For this, I'm going to look to a hard drive-based solution. However, I may want to actually provide high-speed backup recovery services or high-speed file serving services, or we need to solve the virtualization storage problem, so we can use all flash there. In all those cases, you have the opportunity to leverage that same software and think about data protection in a different way. We offer the converged data protection capabilities that are both agent-based and agentless. So depending upon the virtual environment and depending upon the recoverability for each of those VMs, you can decide how you'd like to deploy that. But also the ability to recover any size VM in less than a second with our technology. And this is actually an area where we have a number of patents around that allow you as an agency to actually recover that VM where the VM is running, in VMware, it looks like it's actually accessing the primary storage, when in reality we're recovering that in the background without any additional steps beyond that. So it's very unique to what we can provide in terms of the data protection for dissimilar hardware as well as different virtual environments. But while I mentioned the capabilities of OneTape being converged, there are different deployment options that you as administrators have the option to look at. OneTape can be the primary storage for virtual environments. We can also be the primary storage, which a lot of our customers use for either physical servers or unstructured data, right? And you can even combine the use of the same cluster for multiple purposes. But in that same use case, you have the opportunity to extend that into the opportunity for protecting VMs as a backup recovery target, right? Where maybe it is the primary storage, but a different cluster could be the backup target for your virtual and physical environment. But you'll notice here in the diagram, if you're using OneTape as the primary storage for unstructured data, it's a different way about thinking about protecting that information. Because of our continuous data protection, you actually don't have to back that up in the way that most of us are used to. You can actually rely on the continuous and immutable snapshots every 90 seconds to recover that data, and if you replicate that to an off-site OneTape location, now you've got your 3-2-1 strategy covered in terms of 3 copies of the data, 2 locations, and 1's off-site, right? That is a way that a lot of organizations and a lot of agencies, whether it be education or government, consolidate and think about a storage strategy that provides a unified infrastructure across primary storage as well as secondary storage, and the opportunity to replicate that into our Cloud for DR service or replicate that to another colo. And I've got a couple examples here I'll get to for some hospitals that are actually doing bi-directional replication of their 2 clusters and their 2 sister hospitals. So I'll get into that in just a minute. But it's a different way about thinking about things. So coming back to kind of what's unique about OneTape, no more LUNs and volumes, no more how much storage am I going to allocate to one server, and then if that grows faster than I expected, now I have underutilized storage somewhere else. A pool of storage can be used by multiple applications and clusters, as well as the opportunity to provide high-speed recovery services. So with OneTape and our all-flash solution, if you're looking at data protection, you can actually protect dozens of VMs and have an entire host running 20 or 30 VMs back up and running and booting in just a couple of seconds. And then in the background, your recovery process is now running at all flash speeds as opposed to hard drive-based speeds. But because of the affordability and the economics that we provide, all flash is more affordable than it's ever been with OneTape, and where you're looking at 20, 25 cents a gig as opposed to multiple dollars per gig oftentimes from some of the highest performing solutions out there. But the thing that you need to think about as you're growing and looking at the uncertainty over time is that with OneTape, you can start with what you need. You can start with a single node in your cluster, right? Handful of terabytes. And as you grow over time and add multiple nodes to that cluster, because we're an object store underneath the covers, your pool of storage just increases. You do not have to reconfigure your applications, change the way your users have the map network drives. All that remains the same. The access to the storage remains the same. They just see more storage capacity behind that. And that's something that's really important, particularly as you look at the opportunity for providing an agile storage infrastructure, but also when you're looking at retiring and upgrading your infrastructure, right? In this case, you can simply evacuate a node or 2 nodes that are now 3 and 5 years old and we will migrate that data to the remaining nodes in the cluster, unplug the old hardware, and now you have everything running on the new hardware, and your applications don't know that anything has changed other than the capacity may have increased or may have changed. But it's a way to insulate you as administrators from needing to spend much time managing storage in terms of heterogeneous and forklift upgrades. But one of the things we've done with one system, which is how you manage your storage and data protection, is really reimagined the administrative functions that you as a professional need to worry about. We've simplified the administration to where minimize the number of clicks that you need to do to get things done. There are no command line operations you need to know. Everything is cloud-based, web-based, that you can log into and monitor your storage and manage multiple storage clusters from anywhere in the world. So if you're an agency that has multiple locations, you can manage that storage in multiple locations through one browser, through one account. And even things like setting up remote replication, where you can replicate between dissimilar storage configurations of an all-flash to a hard drive base, or from a 10 terabyte cluster to a 100 terabyte cluster. As long as you have a pool storage that has enough capacity on the source and the target, you can do the remote replication. And that actually is something that you can set up in 3 mouse clicks. No longer do you need to worry about which size LUN and volumes, how many am I going to replicate from my source to the target. All that complexity goes away in favor of just a pool storage. And so as you take a look at opportunities for unstructured data, apologies, looks like the build on this slide is a little off here. But this is where, with the multiple use cases, you can create shares with different storage policies. So I can create an NFS share for my high-performing file serving for CAD/CAM, for my design files. For in my educational doctorates, I can give another SMB share for file serving. And all those shares can have different policies between the type of deduplication. If it's a CCTV feed share, turn compression off. You're not going to get much benefit there. In taking snapshots, the snapshot frequency always remains the same, every 90 seconds for the first hour, then hourly for the first day. But you can determine how long you want to keep that. And on one share, you may want to keep snapshots for a year. On another, it might be just an hour. It might be 7 years. And you can actually figure out over time how you want to scale out and where you want to replicate that data. But by having the primary storage be OneTape for the unstructured data, it dramatically simplifies not only the data protection side of things, but also how do you recover from ransomware, right? And unfortunately, StorageCraft, we've had a number of customers that have been infected with ransomware, but fortunately, every one of them that we know about has been able to get the data back. In fact, even to the point where their backups were, this is a Veeam backup deployment, those Veeam BBK files were encrypted via ransomware. All the primary storage for their users, the VDI infrastructure, was also encrypted with ransomware, and so they couldn't get the backups back. The primary storage was clearly corrupt, and with our snapshots, they went back and got everything back to recover everything that, in this case, it was a major hotel in New York, to get everything back. So there's an opportunity to think about data protection in a different way, because as you look at the ransomware, the way we take snapshots, the way they're immutable, it is an insurance protection. And especially in some of the healthcare organizations, it's a way to underwrite the insurance policy of the risk for a medical record being exposed via ransomware. Oftentimes there's $1 per record at the hospital, depending upon the type of data, et cetera. But this is something that we combine with encryption at rest, continuous snapshots, and remote replication. You can provide very easy recoverability in the event that you find that a user has their PC infected, maybe the entire map network drive and that map share is infected now. But you can navigate to points in time via the snapshot directory to find out where that original file is in terms of the clean file. We will write out the encrypted files to the cluster via ransomware. However, if you're going to write out 500 gig of encrypted files, the original 500 gig of data is protected via the immutable snapshots. And that's what this screenshot is showing you, that you can go in as an administrator, navigate the time and point in time where you want to recover a file, folder, or share prior to the infection, and you can recover that information. So there are a couple of questions that have come in, but before we get to those, I did want to share a couple of examples and a couple of use cases that I was describing a little bit earlier where, yes, these are larger deployments here, but as I mentioned earlier, you don't have to start with the petabyte. And this Oregon public utility, I can't name them by name explicitly, but they're a public utility in the state of Oregon. They actually started with about a third of this capacity based upon their backup recovery requirements. And this is a combination of SQL dumps for critical databases for the state, but also for Veeam backup for other virtual applications. And they grew over time simply by adding multiple nodes in the cluster. And they also grew the remote cluster for the remote replication at the same time. So they just continued to scale over time, and every time they added more nodes to the cluster, Veeam just simply saw as a data repository another 200 terabytes or another 300 terabytes. So it's very seamless from that perspective, as well as when we do the remote replication, it's very efficient for network bandwidth in that we only replicate the changed, I should say the deduplicated objects and compressed objects. So if you back up 100 gigabytes of data, that 100 gigabytes of data is going to be deduplicated and compressed into some number of objects. And if those objects already live on the remote cluster, we're not going to replicate them again, right? We'll just be able to provide pointers, if you will, back to the file for that backup at that point in time to enable recovery. The other thing, the other example I wanted to share was more of a primary storage for file serving. This is a large county hospital. They have more than a petabyte of storage deployed. A few different groups within the hospital, but I mentioned that they also have a sister hospital across the county, far enough across from a DR perspective, that they actually share an infrastructure. They each have OneTape clusters in both locations, providing health records, repository for archiving, but also primary file serving for different doctors and different groups within the hospital. And they really wanted to be able to scale out over time. They came from a legacy scale-out architecture, a different storage vendor. They're now using OneTape for this because of our immutable snapshots, the ability to recover from ransomware, and because in a single cluster, because you can replicate select shares, you don't have to replicate everything. Those two sister hospitals are actually replicating to the other cluster. So you've got cluster A and site A replicating to site B, but then you also have read-write shares in site B replicating over to site A. And so it's a way to really insulate and share some of the network and infrastructure costs for the storage. This hospital is actually fortunate enough to have that. If you as an agency have another COLA, you can certainly do that. The other thing I wanted to point out is that another example of the multiple use. I mentioned the primary storage for unstructured data, as you see this the county hospital doing, but also from a backup recovery repository. MIT Plasma Science and Fusion Center has been a customer of StorageCraft and Exablocks originally for years. They were in the significant challenge of the different doctorates and students that are literally trying to recreate the energy of the sun with the Plasma and Science Fusion Center group within MIT. They had lots of silos, and so different groups had, they would buy 10 terabyte of storage, and that would be one island. And as they needed more, they had to do that. And they did this every 3 years. They were trying to plan what they could do, and what they found is they were actually restricting what the doctorate students could do and experiment on, because over time, the frequency of experiments that they were able to run continued to increase because compute power increased, but the output of every test result continued to consume more storage than it did in the previous years. And they wind up running out of storage periodically, and so they really wanted to scale out infrastructure that they could grow and add storage as needed based upon new tests, new retention requirements for this, right? But also the ability to have that cluster be highly available. So in a multi-node cluster, if a single node goes offline, or 12 or 17 drives and that entire node goes offline, the cluster is still available for them to continue their research or to continue to have the backups be written to this cluster. In this case, MIT uses Veeam with OneTape as a backup target for Veeam, which is perfectly fine. But the other thing that it was really an insurance policy for them was our object storage. Because it's not RAID, they could rebuild drives more quickly. When I say they, our cluster would rebuild that drive more quickly than a traditional RAID set with less performance implications during that rebuild time. as well as the ransomware protection for their research, right? As Otto mentioned, education is oftentimes targeted for that because, just like hospitals, high value, critically important information about their research that if it's compromised, that grant that they receive to deliver the work, they're in a difficult position if they are infected. So being able to recover from that, from a traditional backup recovery sense, absolutely important. But also being able to recover the primary research application data is also important via the continuous snapshots. So I kind of wanted to share with everybody a little bit about what StorageCraft is doing, what's unique about us, as well as the different deployment options for a converged scale-out storage solution that can include data protection, or it could just be storage, or it could just be data protection, but really a way to rethink a storage infrastructure that's going to be flexible to agencies that need to adapt to changes that are coming down the pipe that unfortunately none of us have a great crystal ball for. But that's really where StorageCraft is here to provide an infrastructure that's flexible to changing needs over time. Paul, why don't I turn it back to you? I know there are a number of questions that have come into the chat window here.
Thank you, Sean, and thank you, Otto. Since we're getting close to the end, let's jump right into the questions. First off, many people have been asking about getting copies of today's presentation. So within the next 48 hours, Government Technology will provide all the attendees with a link to the recording, either to use for your own reference or to share with colleagues. All right, so let's get to our first question. So this one is, what can we do to reduce the possibility of the Baltimore ransomware event happening in our environment? And I think we can just broaden that to, what can we do to reduce the possibility of ransomware events happening in our environment? And Otto or Sean, either one of you jump in.
Yeah, I'll start, Paul. A couple of things. Obviously, Sean was talking about, technically the sorts of infrastructure that you can put in place to give you the resources and the ability to minimize the opportunity for these sorts of things to occur to you. I would add that, number one, try to get the organization's appetite for risk determined. It's really hard if you don't know what the organization is willing to, in essence, open themselves up to. It's really hard to then determine the degree to which what options are available, what the costs of those relative options are to the amount of protection that you can achieve. And so it's an approach I've taken over the years, is to determine that appetite for risk. The second thing is make sure you educate your IT staff. Now, most people would feel, yeah, we'll do that, but it's amazing how many times things are accidentally made available or that are just not implemented properly. And so you need your IT folks to be educated. And then in the education vein, educating the workforce, to me, is probably one of the biggest things you can do to ensure that ransomware, phishing attacks, those sorts of things can't take hold in the organization if you've got a smarter, more aware workforce that is not falling prey to the various techniques that the bad actors are making use of out there. So those are some things I would suggest you take a look at.
Yeah, Otto, I think those are great points. And one of the things in terms of measuring the risk, in terms of the risk tolerance for either the agency or the school, is to provide costs and consequences. And then before you actually have and go through the effort of developing a solution to protect against that, based upon the risk assessment that the agency wants to do, then you're going to have some idea of budget, because you can come up with a very expensive solution to be completely all-inclusive, but at the same time, if the organization is not going to carry that risk and they're going to accept that risk for a lower budgeted solution, you should know that ahead of time before you go in to design it. And one of the things, Otto mentioned, to kind of test and educate the employees, that's absolutely something that's important. Just like you test a DR strategy, ideally once a year, have, something as simple as the IT organization, IT group, run the help desk of calling a user and saying, hey, you need to reset your password, give me your old password first and we'll reset it for you, right? Something as simple as that, might kind of scoff at that, but providing employees with dummy phishing attacks for education is absolutely a best practice.
Great. So the next question that we have up here is for Sean. Are heterogeneous clusters supported?
Yeah, good question. So yes, heterogeneous clusters are supported, with a little bit of a clarification. Within the hard drive-based model, so in this case the 44 series, or earlier customers of StorageCraft, they might have the 4312 model. You can add the 44 series to the 4312 model. So we do support heterogeneous clusters from that perspective. We don't support heterogeneous clusters today for the hard drive and all flash in the same cluster, but you can have separate clusters of all flash and capacity-based clusters, and they will all be managed similarly through one system.
All right, cool. So how quickly can a share be recovered with remote replication, Sean?
So it's actually 3 mouse clicks. It's actually the same, very similar workflow to setting up replication, except in this case, you're just selecting the target share, the read-only share, and in 3 mouse clicks, it's now read-writable, and that is actually live in a matter of seconds, a second or so, as of the last recovery point, right? And so, and then you're off and running with the target share being read-writable for your users.
Sounds easy enough. Here's another OneSafe question. When adding additional OneSafe to a cluster, how much downtime is involved?
So when you're scaling out a cluster, there's actually no downtime involved. It's non-disruptive, so you simply plug in network power, drives, and turn it on. That discovers the other OneSafe on the same network, and you click one radio button to join, and you're done. And so the applications don't need any downtime. When that cluster comes up, in a matter of minutes, they'll see the additional storage capacity, and you're off and running.
All right. Well, we are getting close to the end of our time here. I want to give both Otto and Sean an opportunity for any quick, current tweet length parting comments before we wrap it up. Otto?
Again, I think that this is an area that folks need to pay more attention to, because we've seen the devastating consequences of falling prey to things like ransomware, and it really can impact an organization, not just during the, quote, incident itself, but for a long time thereafter, as well as some entities are being repeatedly hit. So I would say that this should head up on the priority list for IT organizations and their CIOs.
Good advice. Sean?
Yeah, I think, coming back to one of my first slides, it's not a question of if, but when. And I think if everybody takes the strategy of when, and then assess the risk within the agency or the university that wants to determine and create a solution for that. But you've got to create an agile solution. There are different recovery requirements you're going to have for different types of events. One of those events may be ransomware. The other event might be a network outage, right? These are all things that it's a tough job and it's a difficult problem to solve. But taking a step back and looking at the bigger picture is important.
All right. Very good. Well, I want to be respectful of our 1 hour commitment, so we'll have to wrap it up here. In closing, I would just like to thank everyone for joining us for today's event, and a big thank you, of course, needs to go to Otto and Sean. And a special thanks needs to go to our sponsor, StorageCraft, for enabling us to bring you this worthwhile discussion. Finally, thank you all once again. We look forward to seeing you again soon at another government technology event.